So these values for the return periods are for the trended data, are calculated for the lake stage, the lake elevation, or for the detrended data.
Yeah, the observed ones are calculated from the observed data,
Yeah.
and others are from the synthetic data.
Synthetic, but detrended.
Without trend.
Without trend, because you removed the trend before.
No, but then we made back transformation. What I remember, whatever we removed, we then inserted back. What I remember, if I'm not wrong.
But assuming that these values are calculated for planning, as you said, and planning usually refers to the future.
Yeah.
You say that these trends that you observed will repeat again in the future.
Yeah, sure. Yeah. Yes. Yes, that's right.
So perhaps you should also model statistically the trends.
Yeah. Okay. Yeah.
And in this case, you will conclude that the trends are not there, and
Okay.
you have a more complex stationary model.
Okay. Yeah, I understand your comment and maybe question. So indeed, this was the concept. The whole idea was for a master student who is now lost. As I said, I mean, lost doesn't mean that she is not present anymore, but she has no relation with university anymore. So we needed to make her job as simple as possible for her to get her degree. So I believe in my standard there was enough for her to get her degree. And since then, I couldn't find any other student to continue, maybe with your idea. But I promise to do next. Yes, please, if there is any.
To pursue this work, basically, it may be a good idea to use the shifting level model that has been developed by ICSH-IAHS to model the whole sequence.
So I cannot hear you. I'm sorry.
So to pursue this work, probably it's a good idea to use the shifting level model that's been developed by ICSH-IAHS to develop basically stochastic model for the whole sequence. And I wasn't sure about the number of years. You said that there are 64 years of data, right?
Yeah,
It
64 years.
you had around 600 or 700 months. There should be much more than that, 700 months.
700 something, 760.
You should be having about 3 times at least as much data.
Really? Anyway, so it was 768 multiplied by 12. Yeah.
So, I see. So it's 700.
60, 12.
Is it? Yeah, 640 and 128.
Why did you opt to use months?
Sorry?
Why did you opt to work with the monthly values?
From 1943 to 2007. This is the 1 month. We have only monthly data here. So
Yeah, I mean yearly. Why don't you use yearly then?
Okay.
Remove the seasonality, and you have enough years to basically.
I see. I'm not sure. I think we started with yearly one, but I'm not sure if we really had this result in the thesis or not.
Well, because you filter basically you filter all the noise and you remove the seasonality.
Yeah.
So it may be easier afterwards to apply the shifting level model.
I have an objection because in this graph you can see that the intra-annual variation is much lower than the inter-annual variation. So for me, this graph is very important on the monthly scale.
But I think, of course, 64 point is enough to construct a model. So we can also start, as Tawad has said, we can start with annual data to construct a model and compare at least the difference in results. Why not? Yeah, of course.
And you may have hidden Markov model in there. I don't know the work that Catherine Wilcox is doing. You may be able to build basically a model with two chains, two Markov chains, and you're going from one state to another. Basically, I don't know. But I would start with the shifting level model, absolutely, if you have another student.
Each model for each segment?
Well, you would have a couple of states or 3 states, and you're going from one state to another, and you're modeling basically each state is an occurrence of the Markov chain, and then within each one you build your own.
This is really possible. Yeah. Thank you.
Thank you.
Another comment is about the when you do the trend with a linear trend, you do the trend with the 4 segments. The parameters of ARMA 1 changed, and it should be. I mean, my vision. It means that the trending affect also the hardest properties of the series because the ARMA +1 but changed significantly. So it is. If you remove just the linear trend, you are probably destroying some of the behavior of the 10 series. So it's, I found it interesting.
Okay. Is there a link with the earthquakes?
At that time, many people were talking about the reason, but geologists finally went, as with Klemesh, went back to 3 rings. They went to their old, let's say, geological levels of the lake, and they found that in the past they had this kind of fluctuations. But it is not enough to discover from this time series, because here we have only positive jump, but they said that in the old, there are some times that the lake had a lower level than this one.
Okay. Very good. So I think we can go ahead with the presentation of Steven. So, some issues in defining information content of hydrological tank series.
Well, thank you very much. Indeed, we are 4 as a team, 2 men supported by 2 women, so you should expect a lot, but please don't expect too much. We applied only a very simple technique, and it was made by the first author as her PhD, master thesis 4 to 5 years ago. And since then, she is lost, but we compiled information from the thesis we had and all the documents that we had with support of the 4th author, who is vice president of International Commission on Statistical Hydrology. She was supposed to be here, but she was not able to come, so I have to mention her very best regards for all of you. We are going to talk about Lake 1, which is located in the eastern part of Turkey, and indeed our motivation comes from because of a monster. Monster, yes, came due to this time series. You see, there are some jumps, and when these jumps happened, everybody was looking for a monster creating this jump. Even a journalist or a journalist from a very serious TV was there for more than a week to just have a picture of the monster, but he was not able to see such a monster. But the town now have a statue of monster. And indeed, I was thinking to go to YouTube to show many videos on this monster animations. But anyway, if you go and when you write down monster of Lake 1, then you get many animations, funny animations. Indeed, this Lake 1 is called indeed as a sea by people there, and this area in Turkey is Kurdish region, and Kurdish people has no sea, of course, So Lake 1 is a very huge amount of water for them, and they call it not lake, but sea, bahr, which comes from Arabic, right? So even this has been an argument between current prime minister and opposition leader, who had 2 years because of his father appointment as a state employee. And in one of his speech, he mentioned the lake as a sea. And the day after, the prime minister said, okay, we have an opposition leader who doesn't know the difference between the sea and lake. And the prime minister comes from Black Sea region. Of course, for him, it's a lake. Anyway, so it is a huge storage. And when we have this increment in this time series, even people were thinking about to have a spillway from this lake and to generate electricity, because there is no outlet of the lake, only evaporation. But the combination of the hydro, meteorological, and maybe tectonic or geological conditions cause this kind of fluctuations. And in the past, geologists say they always have this kind of jumps. So our motivation comes from this, and this is the tectonic map of this region. And even last year, less than a year before, 2 subsequent strong earthquakes hit the town, and thousands of people died because of this. Yeah, this is the monster. Okay, we will see. This is a video shot in 1997, but partly. So Lake 1, we have a gauging station measuring the level of the lake, from which I took the time series that I show you. And this is again the same data for 64 years, monthly lake levels from a reference level given in centimeters. Very simply, if we apply a kind of autoregressive moving average models, and we check the models, and among them we found the second order autoregressive model is the best. And of course, for this we need to take the trends and periodicities out of the time series, and for this we use this software that we have developed some years before. And by using this software called Segmenter, which is available online, if you are interested to have it, I can give the link to you. You can download it, and this program or software is able to make jumps to determine jumps or shifts in time series 10,000 items long in seconds. It is and it uses different methods for jump, different type of regression, constant or linear, different use different tests. Anyway, so it is freely available. Just let me know, or you just write it down on the internet. I believe you will be able to get it. And it is made by 2 more colleagues of mine, and by using this segment, of course, it works deterministically, and it doesn't know anything about the physics of the time series that you have, so you can divide it in as many pieces as you wish. So if you have 1,000 year time series, then you can divide it into 1,000 pieces. But of course, most of them will be meaningless. So this is the report that this program gives. Of course, we checked the time series and found that it could be meaningful if we had this only 4 segments. And these are the trends that we applied by using this program. And these are linear segments that we have. Each segment has its own mean, of course. So by using this 4 trend, or if you want, you can have a higher order segmentation, but we don't use it, just to show the ability of the program. Okay, so what we did, we have our data, as I said, and we determined the segments by using the segmenter, and trends are there then, and we remove the trends, then we determine the periodicity if available, and we removed the periodicity, and then standardization. These are all known application flowchart of autoregressive moving average models, and then we found the best fitting models, and then we applied this model to generate some synthetic series to generate some water level, for example, 1 year long time series. And if we use the one trend line, then this will be the case. Of course, we have right to do so. Nobody can say why, but we made a difference, or we checked the difference between one trend line and 4 trend line models. So this is the aim or of this study. When we have one trend line, when we remove the trend, we got this time series, and we remove the periodicity, then we have this one. And then by checking the best model, we got the second order autoregressive model with parameters given there at the right bottom corner. And this is when we have one trend line for our model. And then the observed and model the data fit, of course, but this is only calibration. We have no validation step for this model. When we use 4 trend line and do the same thing, when we remove the trend and periodicity, again, we found the best model as the second order autoregressive model, and with parameters there, and then these are the results. So they fit. If you use 28 trend line, which is meaningless, of course, just to show, will be better. So this shows when you increase the number of segmentation, then results will be better. But of course, then you will have you will lose the parsimony and meaning, the physical meaning of the time series. So this is just to show. This is not that we applied. Anyway, so we generate a synthetic time series, 1,000 year long, and compare one trend and 4 trend series lake levels, and we found that when we use 4 trend synthetic lake levels, we see that depending on return period, if we think in an engineering point of view, then we will be in a better, in a safer side. We will be in safe. It will be safer if we use the 4 trend model, because if you compare 50-year return period lake level, when we use a lake level used by one trend, we got 391 meter lake level, but when we use the 4 trend model, then we had 400 meter, which is about 10 centimeter higher. But of course, when you are in the seashore or lakeshore, then 10 centimeter can be important. So this is what we had. This was indeed our aim. So as a conclusion of the master thesis of our co-author, my student, so she said, okay, I defined a stochastic model for monthly water level of Lake 1, and she said, okay, I did 2 models, one with 1 trend and the other with 4 trends, and I compared them, and she arrived at the conclusion that I just shared with you. If we use a 4 trend model, we will be in the safe side for planning purposes, and this is what I would like to conclude with you, and I thank you on behalf of this.
Thank you, Hafid.